Hello and welcome to the Math Studio. In this video, we're going to look at differentiating the function y equals the square root of x by first principles. And to save some time, I've pre-written the proof, but I'm going to go through that with you to assist your understanding. Now, this proof is based on the alternative limit definition of the derivative, which is y dash equals the limit as x approaches c of f of x minus f of c over x minus c. Okay, so our first step is going to be, let's just substitute the f of x and f of c with the actual function, the function itself. So y dash is equal to the limit as x approaches c. Now f of x is replaced with the square root of x, because that's what f of x is. And f of c is just the square root of c, so we're just replacing the x with c over x minus c. Now we have a problem here in that if we apply the limit now, and you let x equal c, you're going to have a division by 0. So we're going to deal with that by rationalising the numerator, strangely enough. I know usually we rationalise the denominator, but in this case, we're going to rationalise the numerator. And we're going to do that by multiplying the numerator and the denominator by the conjugate of the numerator, which is square root of x plus the square root of c. But you've got to sort of do the same thing top and bottom, of course. So when you multiply the numerator, you've got to also multiply the denominator by the same factor. So now notice that you have a difference of 2 squares in the numerator there, so that's sort of a nice consequence of multiplying by the conjugate. It'll rationalise the numerator. So what you end up with here then is y dash equals the limit as x approaches c of x minus c over x minus c multiplied by the square root of x plus c. Now you'll sort of have a nice thing occurring here, which is the numerator will cancel with the factor x minus c in the denominator, and then you end up with y dash equals the limit as x approaches c, 1 over square root of x plus the square root of c. So what's nice about this is that you will not get a division by 0 if you apply the limit. So I think it's safe now that we can apply the limit. So now apply the limit by letting x equal c, or we can let c equal x. Either way, we're letting the x and the c being sort of equal to each other. So what I'm going to do is I'm going to replace the c with an x, and we end up with y dash equals 1 over the square root of x plus the square root of x. And of course, that we can sort of collect the like terms, and we end up with y dash, or the first derivative, is equal to 1 over 2 times the square root of x. And of course, you can differentiate this using a fast method, and of course, you'll end up with the same thing. But I think it's good to be able to see sort of how we arrive at this result by first principles. Thank you for watching.